the periodic table. That means the modern periodic table. And the elements in the modern periodic table about groups, the periods, and how many periods, how many groups, how many elements present in each period. So all these concepts in the previous classes we have discussed. To understand the periodic table completely, we need to know about some properties, some periodic properties. So in this class we are going to discuss one of the periodic property that is helpful for us to understand the periodic table completely. That is the atomic size or atomic radius. Atomic size or atomic radius, both are the same. What is an atomic radius? How can we define this? So atomic radius is the distance between the nucleus and the outermost shell of an atom. That means if you take any atom, let us suppose if we take sodium atom. Sodium atom has 3 shells. We know that because sodium atom is present in the third shell. That's why sodium element has 3 shells. So that means in the atom of sodium, the distance between the nucleus of the sodium atom to the third shell, because third shell is the outermost shell in sodium atom. So like this we can define the atomic radius. The distance between the nucleus to the outermost shell is defined as atomic radius. We know that atom is the smallest particle which we cannot see with our naked eyes. And the atomic radius, it is too small distance it is. So we cannot see this distance. That's why this distance is a small distance, and the units which we are using to measure the atomic radius are picometers. What is a picometer? One picometer is equal to 10 to the power of minus 12 meters. That is too small distance it is. Because the atomic radius is a very small distance, we are using these small units, that is picometers. And how atomic radius changes in a group or a period. Let us try to take a group. We know that we have 18 groups in the periodic table. Let us take an example, any one group. Let us take the first group. So first group or 1A group, this is also called as alkali metals. And this group starts from hydrogen and ends with cesium. Hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. So these are elements present in 1A group. Let us take this group for our easy understanding. We know that hydrogen atom has only one electron and it has only one shell. So hydrogen atom has only one shell because it is present in the first period. And the next element in the first group is lithium. Lithium has 2 shells. That means the size of lithium atom is little bit larger than the size of hydrogen, because hydrogen has only one shell, lithium has 2 shells. Same like that, the next element sodium has 3 shells. Same like that, potassium has 4 shells. Like that, as the group, in a group, as the element we take from the top to the bottom, the number of shells increases. That's why the size of the atom increases. That means, in a group, from top to the bottom, the atomic size increases because the number of shells in the atom increases. What about the period? In a period, from left to right. So any period you take, the elements from left to right, how the atomic size changes. So we know that, let us take an example of 4th period. The 4th period has 18 elements. And these 18 elements have same positive charge in the nucleus, because all elements present in the same period, so the positive charge in the nucleus increases. Because let us suppose the 4th period, the first element in the 4th period is potassium, potassium atomic number is 19. That means in the nucleus of the potassium there are 19 protons, and in the fourth period the last element is krypton. Krypton's atomic number is 36. That means krypton has 36 protons in its nucleus. See, potassium and krypton both present in the same period, but potassium has only 19 protons in the nucleus and krypton has 36 protons in the nucleus. That means in a period from left to right, the positive charge in the nucleus increases. As the positive charge in the nucleus increases from left to right in a period, the atomic size decreases. So let us have a revision. In a group, the atomic size increases from top to bottom because the number of shells increases. In a period, the atomic size decreases because the positive charge in the nucleus increases. So these are the trends of atomic size in a group and in a period. Let us take an example how to find larger atoms. For example, if a couple of atoms given, we have to find which is larger. For example, let us take sodium and aluminium. Among sodium and aluminium, which atom has larger size? Let us try to know. So the atomic number of sodium is 11. Atomic number of aluminum is 13. That means these two elements present in a same period, that is third period. We know that in a period the atomic size decreases from left to right. So in the third period, sodium element comes first and aluminium comes next. That means after sodium there is magnesium. After magnesium we find aluminium. So as the atomic size decreases in a period from left to right, so aluminium has smaller atomic size and sodium is larger in size. So like that. Let us take one more example. Lithium and cesium. Among lithium and cesium, which atom is larger in size? We know that lithium and cesium are present in the same group, that is first group. So lithium is the second element in the first group. That means lithium has two shells and cesium is the sixth element in the same first group. Cesium has 6 shells in its atomics in its size. So as cesium has 6 shells and lithium has 2 shells only, so lithium is smaller in size and cesium is larger in size. Like that, if we know how the atomic size changes in a group or in a period, we can easily find out which atom is larger in size and which atom is smaller in size. So these are the topics that we need to know about the atomic size.